What's up, guys? Thanks for coming. Today, we're going to be reviewing how to train your own in-house ASR service, aka speech recognition service, from OpenAI's Whisper model. So here, this is our YouTube channel. It has all our text sharing recordings. There are many speech and NLP stuff. And this is the barcode of our QR code of our bi-weekly meetup. Feel free to join our meetup so you get the latest notification of the next sharing. And this is my company. It's called Olewave. It's a data vendor. And feel free to subscribe our channel if you like our channel. So today I'm just talking about the overview, and I will cover more sessions in the following sessions. If you do not have time, here is the summary. First point, OpenAI open sourced a large foundation ASR model. It's called Whisper. You can imagine that it's the large language model in the speech recognition domain. And it made the training or fine-tuning on your own language or scenario-specific ASR model, or both. Way simpler than before. The second point is that to cost-effectively fine-tune and Whisper model, you only need two essences, just two essences. Remember, the first is computational power. You can choose automatically fine-tune service or GPU cloud or DIY your own GPU cluster. Automatic fine-tune service I meant here is any service provided by OpenAI or Microsoft. The second point is that you want to have your own data set. The best data set that is cost effectively is something that's large scale, domain specific. It doesn't have to be well labeled. Weak labeled is okay. And it even doesn't have to be a real data. Pseudo data sometimes are fine. And our company, we are Olewave, we can provide certain type of data. The other choices are you can have a smaller scale, not always domain specific, but well labeled, pre-recorded or newly recorded data from traditional vendors. And also you can do it yourself with your own production data. Although that's domain specific, that won't be very large scale because you're going to be suffering from the time and the cost. And you do not have to worry about the algorithm used in the fine-tuning because there are fairly amount of good ones on the Hugging Face and the GitHub. All you have to make sure that you want to make sure that on the model card of these repos or the recipes, they have something like a benchmark. The benchmark I meant here is something, the model accuracy, latency, etc., before and after the fine-tuning. Okay. What we are a data vendor. So we not only customize the speech database or data set, we also work on text and video stuff. Compared to traditional vendors, we're better in data efficacy, which means before we deliver data to our vendors, different from the traditional vendors, we verify the efficacy of the data. And we are faster in data delivery because we do not heavily leveraging the human beings. So everything is automatic. So we can do faster than the traditional vendors. And also the pricing. And because we are guys formerly AI researchers, we know where the issue is. We can even offer some consulting services. So the question is, you said OpenAI Whisper model is fairly good. What does it offer? So it's a supervised trained ASR model, but that it was trained with the largest data set by far. Well, I think Meta AI people might be disagreeing with me, but it's another story I will cover in the following slides. And you see the keyword largest here. So imagine why the ChatGPT or GPT-3 are fairly popular, or GPT-4 are fairly popular right now. There's nothing fancy in their algorithm. It's just using the transformer blocks, layers of transformer blocks. But they managed to train a gazillion amounts of text from internet, so they are capable of reaching a unprecedented AI model which beats almost every model before the ChatGPT. Well, same thing here. The Whisper model, because they use such a large data set compared to the previous practices, the result is very surprising. I'm not going to talk about the numbers today, but in the following sessions, in the future sessions, I will definitely talk about the exact performance of the Whisper stuff. And if you're cannot wait, I do have a paper sharing of a Whisper published paper. You can search in my channel. It's Whisper Olewave. You will find I read the paper line by line almost. The second good thing of it is MIT license. I would say it's very, very generous. You can use that for commercial purpose, 100%, sure. Which is different than Microsoft or Google. They won't allow you to see their model. And it also supports 99 languages. It's almost covered all the major languages in the world. And because of the second point, it's MIT license. There are many people. They work together to build a ongoing or evolving ecosystem for model tuning, for model compression, and the downstreaming task, etc. And even some people say, okay, the model is too big. I want to try to see if I can get a smaller model so I can deploy that more efficiently. So wait, you talk about so many, you say, okay, wait. You talk about so many good things of Whisper, but what thing is Whisper is not capable of? Okay, there are many. I do not have time to go through all of them, but I will just list the major of them right here. But first is it doesn't have a good accuracy on the low resource languages, for example, Vietnamese and Indonesian. According to their paper, they only have hundreds of hours of training data, and sometimes they're even less than 100 hours for very, very low resource languages. That would make the model work for this language, but not working well for those languages, right? And suppose you are a e-commerce company in the Southeast Asia, you want to have your own speech recognition engine for your customer service phone calls, then you find Whisper is not good for you. The second is that it doesn't have a good support of certain dialects. So you say, our Singaporean people speak English, it's fine, but they speak Singaporean English, which is a dialect of English. And if you're using Whisper model for that, you won't get a good speech recognition accuracy. Also, for certain specific scenarios, the accuracy is not satisfying. For example, medical transcription with medical terms, sales phone calls with brand names and entity names, and also code switching conversation, for example, like I mentioned, the US Spanish. So the Spanish, European Spanish and the Latin America Spanish are different, but also if you look at in the US, when the Latinos are speaking Spanish, they have lots of English words in it. So in this case, it's called code switching. You switch language to language. why they call it code switching? Because in the past, when people make telephony calls, their operator they switch the code for you, you know, so you can be connected to the different line, and this is called switching. And this is how the name comes from. The first one is unpredicted ASR result on new name entities. Webmayama is all over the place, right? But it's emerged after Whisper was trained, and also lots of entity name, new business entities. Whisper won't be able to get those words recognized correctly, reliably. Okay, you may say, okay, Whisper model is trained with word pieces. It should be able to get Webmayama correctly. But if it didn't, let me tell you, there's not 100% guarantee. Okay, if it doesn't, there's no way for you to adjust it, because the Whisper model doesn't have a language model afterward, external language model afterward, and there's no rescoring phase. All you have to do is to fine-tune the model. The first one has hallucination. Like a lot of language models, it also has this issue because it was trained with pseudo or weak label. The labels are not 100% human checked. And also, deployed model might be too pricey compared to the past ASR model, which only needs a CPU server to deploy. Or this model has 1.5 billion parameters. It definitely needs a good GPU machine to put the model on. You may say, okay, wait, what should we do if we want to use the model for my own purpose? Then fine-tuning is the answer. Okay. Especially for the last one, I'm going to talk a bit about this. You can play with something called a transfer learning. And there are some people, lots of open source toolkits for doing this. So you can go from the large model to smaller models and even tiny models. You can put the tiny models on the edge devices, for example, cell phones, IoT device. But in my opinion, okay, although the transfer learning, the inventors of the transfer learning method won't consider this as a fine-tuning, but fine-tuning is always going from one model to another model. So transfer learning falls into the category of fine-tuning. So to solve the issues I talk about here, you have to look into fine-tuning. So how to fine-tune? You have to pay attention to three factors. First, algorithms. Interestingly, right now, if you are fine-tuning Whisper model, there's no secret sauce because it's just the layers of transformer blocks. 6 layers of transformer blocks in the encoder and another 6 layers of transformer blocks in the decoder. And there's no language model. So there are many Hugging Face and GitHub open source repos. They're very good enough. But pay attention to whether they have benchmarks or benchmarking results. The speech recognition accuracy, latency before you fine-tune model or after you fine-tune the model and see what's the improvement you get. You may ask, what if they fine-tune on Japanese and my case is Indonesian? I would say it's okay because usually if you have roughly the same size of the data set, the experience of the transfer learning can be transferred too. So you can use their learning rate schedule in your case, and you should get a good results. Second thing is the computational power. Here, I would suppose that you have a limited budget. You're not like an OpenAI or Microsoft. You have tons of money to spend. You just have to build a customized, order a customized GPU cluster from NVIDIA and play around with it. Then I think the first thing I would recommend to you is the automatic fine-tune service offered by OpenAI or Microsoft. I would definitely cover that in the following sessions, how to do that. It's super simple. If you cannot wait, you just Google the names, Google the keywords. You will landing on those pages. And the second is that you buy the GPU hours from the AWS, Google Cloud provider, Azure, or Microsoft Azure, right? Yeah. Also some other cloud service provider. I think NVIDIA even provide GPU cloud. Am I right? And also some third-party data center vendors. The first one, if you have concerns about your data, you have concerns about privacy of the data you're handling with. You don't want your data to be uploaded to AWS or OpenAI. Then you probably have to build your own cluster or data center. But this is very costly, Most cost effective, the first one. The second most cost effective. The last one is the most costly. Dataset. I think, think about when you fine-tune the whisper model, everybody start from the same foundation model, and everybody using almost the same algorithm, especially a slightly different learning rate schedule that won't make much difference in terms of accuracy. And also computational power wise, I mean, GPUs and GPUs, although they're different, they always get roughly the same result, except suppose you are having a lot of H100, so you can use a very, very large batch size. So your result might be better than others, but not very much. So in the end, what makes you distinguished from the others or makes your model fit your application is that your data, and that's the key. Okay. And even you want to get your data, you also want to be cost effective. There are mainly three approaches. I will start with the second one first, because this is the most common approach. Suppose you want to launch a e-commerce platform with the speech recognition capability, which can automatically handle the customer's phone calls. Okay. And then suppose you're working on Indonesian and you talk to a traditional vendor, not us, we're not traditional vendor. And they say, okay, John, let's see, what do I have? Okay, I have 500 hours. 500 hours is small scale. 500 hours of Indonesian data. It's pre-recorded. What do they mean by pre-recorded? Most time they're having Indonesians come into their studio and read the sentence they give them. So that's called red database. And the problem of this is that the red speech data are different than improvised speech data. So when I'm talking to you, I'm speaking improvised voice, okay? So red speech and improvised speech are different. And then this is going to be causing a performance issue, accuracy issue in the future. And it's not always domain specific. So most time when they record the database, it's more likely these people are talking about the weather, food, politics, not about e-commerce, let alone about the brand's names you're having in your e-commerce platform, okay? And because this is red database, they say this is well labeled. Of course, they only have to have a human being check whether the people are saying the word they're supposed to say. Some traditional vendors may argue that would you record new database for our customers? You're right, but that's going to be taking a lot of time. Suppose you want to, and also that data is not real data, it's pseudo data. What do I mean? By pseudo data? So usually what the vendors would be doing is having two or more persons coming to the studio or put them on the phone, and they give you some general guidance. The two guys are having conversations. They are having a fake commercial buying and selling conversation. It's not real. This is why I call that pseudo data. And when they get this data, they have to have a human beings label everything. And that's very, very time costly. According to my experience, if you want to label 1 hour of improvised speech or spontaneous speech, you have to spend 10 hours per person on that audio. And let me tell you that because a lot of the human laborers are not very motivated because they're paying a very, very minimum wage. So the burnout rate is very high. So those traditional data vendors are keeping getting new data laborers coming in. So the turnover rate is high. So there's no good way for them to track the performance of the laborer. So sometimes I argue that even the result it has been examined or labeled by human being, the result might be not very reliable. And you pay for that. And when the traditional vendors, they offer the data to you, they offered you the data based on the contract. The contract says this is data 100 people, 500 hours. These are data are being examined by human being, right? You don't have the time and the money to hire your human being to check their data, right? And if your model training doesn't work very well, then you're screwed. So because you spend 3 months with them to record this new data set and it's not working. On the second approach is also small scaled, but because suppose you have some product, you have some recordings, then you have your own production data, and this time it's definitely domain specific. It's very, very domain specific, and then you can label yourself or by the vendors, and then you can call this a well labeled or human labeled. But like I said, the quality of the there's always a question mark of how this data are being labeled by human being. The third approach, which the approach I propose or our company values, it's you use a large scale amount of data, of domain specific data, and the data doesn't have to be real data. It could be pseudo data. And the label wise, it doesn't have to be human being. It can be weakly labeled. What do I mean by weakly label? So that label can be just a human checked, not human labeled. And the result could be coming from another speech recognition engine or machine translation results or some unverified human transcriptions. Okay. And our company are capable of offering this. And the good thing of this is that before we offer data to you, we verify the efficacy of the data by training a relatively smaller model on our site. So we know the model or the data is effective. So you can see that we're different than the traditional vendor. Traditional vendors will always say, okay, this is 100% correct, humanly verify the data. But what we are doing is that, look at this. Because for the large, people have verified that in the large language model training, the large scale of data really helps. That is also true for speech recognition. So because we are offering a large scale amount of data, so in this scenario, the weakly or pseudo labeling can be more cost effective than the human labeling in terms of the training ASR with higher accuracy. So you can see that later on, to tell whether the data is effective or not, we're not looking at whether the data has been labeled 100% correct or wrong. We are looking at how well the model is performing after the fine-tuning with our data compared to the traditional vendor's data. Okay. All right. I'm going to be stopping here. In the future sessions, I will talk more details about the three things. I know a lot of you are interested in the algorithm. I definitely can cover that. And also, I'm going to talk a lot of things about how to prepare a good data set to fine-tune the Whisper model. Thanks for being with us. If you like our videos, please hit subscribe button and also share that with your friends. And we'll see you 2 weeks after.